Today our lesson is scientific notation. This is something you should have already in your background of math knowledge, but we're going to review it. So it should be a short lesson just to review scientific notation. Scientific notation is a very convenient way to write large and small numbers and to do calculations with them. They are written using a base of 10, and they're used in all kinds of fields of science and math. It is okay, this is important to note, that I've told you not to leave negative exponents, but it is okay in scientific notation to have negative exponents. So I want to point that out. So you will have negative exponents in scientific notation. This is a chart that you can print out and put into your notes or copy it. It's just a very helpful. When you're talking about a billion, that is going to be 10 to the 9th power. These are some symbols and prefixes. You don't have to memorize those. I just want to kind of go quickly through the chart to go so that you can see the pattern. Million is 10 to the 6. Notice that you have 6 zeros. A billion, you have 9 zeros here. 1,000, 10 to the 3 with 3 zeros. 100 is 10 to the 2 with 2 zeros. 10 is 10 to the 1st with 1 zero. And notice that the number 1 is 10 to the 0. Remember, I always told you that anything to the 0 power is 1. Then if we get into our negatives, you can see that 0.1 is, or 1/10 is 10 to the negative 1. 1/100th is 10 to the negative 2. And 1,000th is 10 to the negative 3. And notice that the 1 is 3 places to the right from the decimal, 10 to the negative 3. 1/1,000,000th is 6 places to the right of the decimal, 10 to the negative 6. And 1/1000,000th is 10 to the negative 9th. So that's where your negative exponents come in. Negative exponents are used to write numbers that are very, very small, smaller than 1. Notice all of these numbers are smaller than 1. So the basic form for scientific notation is this, where C is a number that is between 1 and 10, but smaller than 10, and N is an integer. This is your power. For example, you have 3.2 is written as 3.2 times 10 to the 0 power if you were going to write that in scientific notation. Remember, 10 to the 0 is 1, so 3.2 times 1 is equal to 3.2. 55 10,000ths is written as 5.5, so you move the decimal over 1, 2, 3 places, and because it's a very small number, less than 1, then that's 10 to the negative 3rd, so 5.5 times 10 to the negative 3rd is an example. So let's practice writing these in scientific notation. So you want to write these down. The first example, we're going to write this in standard form. So that means the exponent tells me how many places to move my decimal. Since it's a positive exponent, I'm going to move my decimal to the right. So all I do is take 3.02 and move the decimal to the right that many places, 4. So I'm going to go over 1, 2, 3, 4, and then add zeros. So this number is 30,200. This second problem, I have a negative exponent here, and that's telling me to move the decimal 3 places to the left this time. So I have 9.131, and I'm going to move the decimal 3 places to the left. So 1, 2, 3, and then I add 2 zeros there. So this number is equal to 0.009131. Practice 2 more. This one is a negative exponent, so it's going to move to the left. So I write the number, and the 5 tells me to go to the left because it's a negative. So I'm going to go 1, 2, 3, 4, 5, and add 1, 2, 3, 4 zeros. So that number, again, negative exponents are used to write really, really small numbers. So I have 4 zeros, and then 3 and 7. And the last one for scientific notation, this 3 tells me to move it, it is positive, so you move it to the right. So 1.012, I move it 3 places to the right. So you get 1012. All right, you also need to be able to write numbers in scientific notation. So now we have standard form, and we're going to take standard form to scientific notation. So remember, the first number is a number that is between 0 and 10. So that means I'm always going to put the decimal after the first digit. So I have 3.97 is going to be the number that I multiply. And then I count how many places I had to move the decimal. So I moved it 1, 2, 3, 4, 5, 6, 7, 8. So I moved it 8 places, and it's a very large number. It's not a number that's less than 1, so I know my exponent is an 8, positive 8. All right, here I look at this number. I want to put the decimal in between the 7 and the 1. It's always after the first non-zero digit. So I have 7.12 would be the first number, and then I have to count how many places did I move the decimal. So I moved it 1, 2, 3, and 4. Now this is a really small number that's less than 1, so you know it has to be a negative exponent. So I moved it 1, 2, 3, 4, so this is negative 4. You can also focus on which way you're moving the decimal. I moved the decimal to the right, which means I have a negative exponent. Here I moved the decimal to the left, which means I have a positive exponent. Whichever way, it's easy for you to remember. I like it that it's a very small number. So if it's a really small number, you know it's a negative exponent. So this would be 1.03 times 10 to the negative, and then I just count how many places. 1, 2, 3, 4, 5, 6, 7, 8. So it'd be 10 to the negative 8. The last one is a very large number, so I know that I'm going to have a positive exponent. I'm going to put my decimal after the first digit. So it's 9.12, and then I drop all of those zeros because I don't need them. And then I multiply times 10 to a positive, and then I count 1, 2, 3, 4, 5, 6, 10 to the 6th. Again, this should be review for you. So that's basically how to take a number in standard form to scientific notation and reverse. So now you have homework just practicing this particular skill. Have a great day.